Hello everyone. In this video, we are going to start trigonometry. First, we are going to learn the basic difference between the cases when we have to use Pythagoras theorem and the cases when we have to use trigonometric ratios. We are also going to learn the SOHCAHTOA method of trigonometric ratios, where in which cases we can apply the sine, cosine, and tangent. So, without wasting time, let's do some math. We are going to start from Pythagoras theorem, and we are also going to understand the basic difference between Pythagoras theorem and trigonometric ratios. So let's check. First is Pythagoras theorem. So in Pythagoras theorem, this is a right angle triangle. First we have to understand the Pythagoras theorem and the trigonometric ratios. Both are applicable to right angle triangles. Right angled triangles. Now, but what's the difference? In which case we can use Pythagoras theorem and in which case we are going to use trigonometric ratios. First, let's understand a right angle triangle. In a right angle triangle, in this case, which is at right angle at A, the opposite side is the hypotenuse. The adjacent side is the base, and this side is the perpendicular, also known as the height of the triangle or the altitude, which is perpendicular. Now, as per the Pythagoras theorem, AB square plus AC square is equals to BC square. The opposite sides of each vertex can also be lettered as small letters. So opposite to angle A is small a, the side opposite to angle B is small b, the side opposite to angle C is small c. So in some of the books you might see that it is written as A square is equals to B square plus C square. So this is the Pythagoras theorem. When it is used when out of the three sides, two sides are known to us and one side is missing. So when two sides are known and one side is missing. What about trigonometric ratios? So let's check. In trigonometric ratios, again the labeling remains the same. So if this is the angle theta at vertex C or at angle C, the opposite side will be its opposite, also known as perpendicular P. Side opposite to angle A is your base, so labeled as B or also known as adjacent, and the side opposite to the right angle is known as hypotenuse, and it can be labeled as capital H. So this is a right angle triangle. What is trigonometric ratios? So trigonometric ratios are basically, there are three types of ratios: sine theta, cosine theta, and tan theta. Sine is also written as sine, cos is cosine, and tan theta is tangent. We'll learn more about trigonometric ratios in detail. So let's move ahead. SOHCAHTOA. So this S, C, and T stands for sine, cos, and tan. So what are trigonometric ratios? Trigonometric ratios are three different ratios for sine theta, cos theta, and tan theta. So sine theta is the ratio of opposite upon hypotenuse. What is cosine theta? Cosine theta is nothing but the ratio of adjacent upon hypotenuse. And what about tan theta? Tan theta is nothing but the ratio of opposite upon adjacent. So in which case we have to apply trigonometric ratios? In case where one side and one angle is known to us. So in this right angle triangle when one side and one angle is known, and when we have to find the remaining sides or the remaining angles, in that case we have to apply trigonometric ratios. For that we can apply SOHCAHTOA method, where sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan theta is opposite upon adjacent. This also depends upon the reference angle, in this case theta over here at A. So the side opposite to the angle theta, which is our reference angle, will be your opposite side. This is your adjacent side, and that the longest side, which is always opposite to the right angle, that's your hypotenuse. So whenever one angle and one side is known to us, we can use a specific trigonometric ratio which is applicable to find the other side. Now with a few questions to understand it better. So let's try question number 1. So this is a right angle triangle, x, y and z, right angle at x. It says calculate the length of yz, give your answer correct up to 3 significant figures. So here two sides are already known to us and one side is missing, so we can simply apply Pythagoras theorem. To find the missing side. So simply this is the opposite side, which is hypotenuse. So to find the hypotenuse, we can simply apply a square is equals to b square plus c square. But in this case, x square is equals to y square plus z square. So x square is equals to y square, that is 1.7 square, plus z square, which is 3.2 square. So x square is equals to 1.7 square plus 3.2 square, which is 13.13. Then x is equals to under root of 13.13, 3.62. 3.62, correct up to 3 significant figure. As mentioned in the question, we have to write the answer correct up to 3 significant figure. So this is the answer. Let's move on to the next question. Question number 2. Now this is a compound shape. We can see two right angle triangles clubbed together to form one shape, and it says calculate the length of AB. So this is AB. AB is actually, let's say, C, side C. And to find C, first we have to find AC. First we have to find this length AC, which is missing. But ADC is also a right angle triangle, right angle at D. So basically AC square will be equals to 7 square plus 4 square, applying Pythagoras theorem here. So that is going to be 49 plus 16. Then AC is going to be under root of the answer 49 plus 16, which is 65, under root of 65, which is 8.0622. But because it's not the final answer, we'll not round it up. Now let's check the other triangle, triangle ABC, triangle A, B and C, and we have to find the side AB. So now we can do this. AB square is equal, because this time AB is not the hypotenuse, so AB square is going to be BC square minus AC square. So BC square is going to be root 65, no, this is going to be, BC square is going to be 9.5 the whole square minus root 65 whole square, which is 9.5 the whole square minus root 65 the whole square, which is 101 by 4. In decimal we have 25.25. So under root of 25.25 will be 5.02. 5.02. That's the side AB. Correct up to 3 significant figure. It's 5.02. Let's check the next question. Question number 3. It says calculate the length of QR. Give your answer correct up to 3 significant figure. So now when we have to find the length of QR, we can clearly see that this is a right angle triangle, but one angle and one side is known to us. So now we have to apply trigonometric ratios. We can use SOHCAHTOA method. So now we can clearly see that the hypotenuse is given to us and they are asking us to find the length QR, which is adjacent, right? So let's write SOHCAHTOA method and figure out which trigonometric ratio is applicable when hypotenuse is known to us and adjacent. Cos theta will be adjacent upon hypotenuse. So we can apply cos theta is equals to adjacent upon hypotenuse. So cos 43 degrees equals to adjacent, which is missing, which is QR, upon hypotenuse, which is 5.8. So QR will be 5.8 multiplied by cos 43 degrees, and let's do this in calculator and we'll get our answer. 5.8 multiplied by cos 43 degrees, and the answer is 4.24 meters. That's the answer. So this is the final answer, correct up to 3 significant figures. Now we can move on to the next question. Question number 4. So again, this is a compound shape. You can clearly see that a triangle ABC is divided into two right angle triangles, ADB and CDB. It says calculate the length AC, which is this length. Give your answer correct up to 3 significant figure. So now first we can do is we can work out the length AD first. This part, let's mark it as X. Then we can find the length DC. Let's mark it as Y. And then ultimately we can add X and Y, which will give us the length AC. So let's start with triangle ADC, because ADC is also a right angle triangle. And again, adjacent is unknown and hypotenuse is known. So we can simply write cos 65 degrees is equals to adjacent, which is X, divided by hypotenuse, which is 7. So X is equals to 7 multiplied by cos 65 degrees. So the value of X is going to be 7 multiplied by cos 65 degrees, which is 2.958. 2.958. This is not the final answer. We have to write the final answer correct up to 3SF. So we'll write that. This is 2.958. So this is, let me write it over here. So this is 2.958. And now we have to find the length DC. But before we find the length DC, we also have to find this opposite side, because that is going to be used in the next triangle. So that is opposite. So now we can use sine theta, because sine theta is the ratio of opposite upon hypotenuse. So here we can write sine 65 is equals to opposite, that is AD, upon hypotenuse, that is 7. So AD is equals to 7 into sine 65. So 7 multiplied by sine 65 degrees, which is 6.344. So this is length AD, which is, this is 6.344, and we have to find DC. So again, in right angle triangle, opposite side is perpendicular is known to us and hypotenuse is known to us, and base DC is missing. So we can simply do in triangle CDB 12 square minus 6.344 square is equals to y square. So y will be under root of this answer, which is 12 square minus 6.344 square, which is 103.75. So I'll write over here 103.75. So the value of y is under root of that answer, which is 10.185. So the final answer is going to be length AC is going to be x plus y. This is our x 2.958 and y is 10.185. So let's add them. So 2.958 plus 10.185, and the final answer is 13.14. So AC is 13.14 centimeters, and that's the final answer. Just a second. This is the final answer, length AC, which is sum of x plus y. The y is 10.185. With this, we have covered both the topics, Pythagoras theorem and trigonometric ratios. If you have any difficulties in any of the questions, you can surely write it in the comment section, and let me know if you have any preference of any other topic. I'll be happy to make a video on that and make sure that it reaches out to you guys. If you find this video helpful, please consider it sharing with your friends so they can also learn the same. That's all for today's session. Bye everyone.